This is an introduction to molarity. Molarity is spelled M-O-L-A-R-I-T-Y, and it's a form of concentration. And concentration is a ratio of solute to solvent. The first thing you're going to do is make a foldable. You're going to need a piece of paper folded hot dog style. There are 2 flaps, 1, 2, so you're just going to cut right down the middle, and then each flap will fold up. The left side should say how to solve for molarity. The unit for molarity is capital M. The right side should say how to solve for grams, moles, liters, or milliliter. You may want to pause the video at this point so that you can get your foldable set up and ready to go. When you're ready, continue on to the next slide. You will notice that on the left-hand side, flap 1, you're going to be on this part of the foldable. You're going to write 2 things. You're going to write molarity and the equation. It's simply moles of solute for your numerator divided by liters of solution. Liters of solution is your denominator. This equation is quite simple. You just plug in the moles, plug in the liters, and divide. However, you may need to use dimensional analysis first to get moles of solute and or liters of solution. Pause the video until you're ready to move on. For the right side of your flap, we're going to put this information at the top. This is just like regular dimensional analysis like we've been doing for a while now. You start with your given. You cancel your units diagonally, and you continue canceling your units until you get to what your question is asking for. Pause the video until you're ready to move on. On the bottom half of flap 2, you're going to write your various conversion factors. One conversion factor is using molarity as a conversion. Whatever the number is, you'll put it here, and it's that number for moles of solute equal to 1 liter of solution. Another conversion factor is 1 mole of a substance equals formula mass grams of a substance. So these 2 blanks, I can't fill anything in there because you're going to put whatever your substance is in those blanks. And sometimes you'll have milliliters and you have to convert to liters before you can plug in. Sometimes you'll be going the other way, but you always have 1 liter equals 1,000 milliliters as an option for your dimensional analysis. Pause the video until you're ready to move on. So I'm going to go over a couple of questions on your worksheet with you. We did these in class as examples, so since so many people were absent, I thought I'd do them on this video so you can get the examples also. We talked about this first question, what does molarity mean? And we said it is a concentration there are actually a few different types of concentration. Molarity is probably the most common, and it specifically is a ratio between the moles of solute and the liters of solution. And remember, these quantities are straight from your molarity equation that we just talked about. You'll see in question 2, they're asking you to solve for molarity. That means you're going to be using flap 1 of your foldable, how to solve for molarity. So we'll just write that equation down. We've got molarity. Capital M represents molarity. We know we need our moles of solute for our numerator, and we need our liters of solution. A lot of times I abbreviate solution SOLN. It's just a shortcut. So I'm going to circle the two things that we're given. We're given 4.53 moles of lithium nitrate and 2.85 liters of solution. So we will put in 4.53 for our moles of solute and 2.85 for our liters of solution. And you'll just need to divide that. And when you divide those two numbers, you get 1.589. We'll round that to 1.59. You'll see the answer bank has 1.6. So you can call it 1.6 if you want. And then the units are capital M for molarity. There's number 2. Pause the video if you don't have that all written down yet. The next example I'm going to do is number 5. And you will see that this one is just a little bit different. We're going to go ahead and circle what we're given. We're going to put a box around the word molarity because that's what they're asking us to solve for. Since they're asking us for molarity, we know we're going to use flap 1. So we know we're going to plug in the equation. We need moles of solute, and we need liters of solution. Now, one of those numbers is given. We can do the 0.0673 liters of solution, and we can plug that straight into the denominator. But we aren't given moles, we're given grams. So we're going to have to convert our grams to moles before we can plug it in right here for our numerator. You'll also notice that the formula isn't given, so just down here where I have a little space, I'm going to figure out the formula. Chromium 3 means its charge is plus 3. Fluoride is capital F and its charge is minus 1. This balanced formula is going to be CrF3. So we write that right here in this box. You have a formula chart for your formula mass, so you just list your elements, Cr and F. Chromium subscript is 1. F subscript is 3. The atomic mass of chromium is 52 from the periodic table. Fluorine is 19. Multiply across, we have 52. 3 times 19 is 57. 52 plus 57 is 109. So with using the formula mass, I can convert my 214.2 grams into moles. So we'll set up a little T-chart. And we'll start with 214.2 grams of CrF3. We convert grams to moles. We know that our formula mass means that we have 1 mole equal to 109 grams of this substance. We'll do 214.2 divided by 109, and we get 1.97 moles. That is our solute. So now that we have it in the correct unit, we can plug in 1.97 moles in our numerator. So we'll do 1.97 divided by 0.0673, and we get 29.27. That rounds to 29.3. I'm running out of room for my answer, so I'm just going to write it up here at the top. And again, we're solving for molarity, so the unit is capital M. There's just one more example to do. You'll need to pause the video if you don't have that all written down. And our last problem is number 9. I chose number 9 because in this question they ask for mass instead of molarity. We're given 2.5 liters and we are given 1.06 molar. Since we're not solving for molarity, we're going to use flap 2 if you want to reference your foldable. And I also want you to go ahead and write your 1.06 molar in a different way. You're going to write 1.06 mole equals 1 liter of solution. So I'm gonna write something here at the bottom of this slide, and I recommend actually that you put this on the back of your foldable. This is the path that you can go for flap 2. You can go from grams to moles to liters into milliliters. And you see I made all the arrows double-sided because you can go either way. And for our question, we're starting at 2.5 liters and they want us to solve for grams. So our dimensional analysis problem is going to start with liters, then moles, then grams. So I've got liters, moles, grams. So we're going to put our given in the first spot, 2.5 liters. We know our rules of dimensional analysis say if I have liters here, I have to have liters here to cancel. So I'm also going to cancel moles in the same way. To get from mole to liter, or actually from liter to mole, I'm going to use this conversion factor. And it says 1.06 with moles and 1 with liter. And then for my conversion factor between grams and moles, I have to do a formula chart. So that's why I've got this over here. I've got Li, got P, O, Li, there's 3 of them, 6.9. P, there's 1, and it's 31. O, there are 4, 16. We're just going to multiply. Add those all together. So now I have 115.7 grams in 1 mole. So we actually set this whole problem up in one step. You're just going to multiply 2.5 times 1.06 times 115.7. We're not even going to worry about these ones. Dividing by 1 isn't going to change anything. And our answer is 306.6. Our liters cancel, our moles cancel. We're left with grams. Remember how the question asked us for what mass? So that makes sense because our units are grams. We should go ahead and put the substance in as Li3PO4. Now with those examples, you should be able to do the rest of your worksheet on your own.